Hello and welcome to Friday afternoon TGI Kubernetes. I am your host, Kris Nova, broadcasting live here from the Heptio studios one more time. How is everyone doing today? It's really great to see everybody. Let's do my favorite part of the week where we get to go through and we get to say hi to all of our friends who join us for TGI Kubernetes every week and see where folks are joining us from. So let's see. First person to say hello was Olav, so Olav wins for this week. Next off, we have Fabian D, which I believe, Fabian, you've been helping me behind the scenes with KubeVirt, which is what we're doing our episode on today, a little bit in the Kubernetes Slack. And if you're the same person, I just wanted to say thank you so much for all your help. It was really wonderful, and it's making the episode going to be a lot more exciting because of how we got some of the kinks worked out earlier. Okay, so next we have Bazbank says yo, Charles says hello, Peter says yo, Suresh yo, lots of yos today. It's a yo kind of day. Martin says yo, Lamati, good to see you. Lamati always joining us, one of our regulars here, one of my favorite people. We have Martin, they say yo. Charles, at Charles Pretzer, you gotta follow convention. And then Heptio says, yeah, okay, so let's see what George says in the Heptio channel. So George is helping out with the Heptio user today, so if you need anything, George can help you out. Just ping the Heptio person there. And George says, welcome everyone, this is George. I'll be helping Kris today. And we'll start in about 6 minutes. So after that, we have Herman says, good evening. Charles is still talking about yo. Gage, hello, the big smiley face. David, howdy. Excuse me. Christopher says hello. Ismail says hello. Zolt says hello. Ali says hello. FS Daniel says hello. SK says hello. Sandeep. Okay, and then George dropped in a link here. If folks want to look, it's over on the right side in your chat. It is our HackMD, which is an interactive document that we can work on together. It respects GitHub Markdown, and that's where we keep all of our show notes. So if you want to click on that, it's going to have links and pointers and hopefully some good information as we learn about KubeVirt and a handful of other things here in the Kubernetes space for the week. So next up, we have Ismail, says hello from Ankara. We have Saeed from London. Hello from Chennai. Hello from Germany, Istanbul, and Rotterdam. Alrighty, well, I'll come back and I'll check the chat a little bit more. If folks want to start trickling other hellos in, I'll come back and do one more read through and try to get your name out there for you. Also, friendly reminder, let's see if I can do this right. Where is it? Hit that subscribe button right there if you haven't done it before, so that you get reminders every week for TGIK, brought to you by VMware. So anyway, a little bit about me. My name is Kris Nova. I'm a developer advocate here at VMware. I used to be a part of Heptio. We joined up with VMware, and I'm here at our Seattle office. I thought last week was going to be my last week, but I think it's going to be this week. But it's coming soon. And then I'm going to move over, and I think I'm going to start doing TGIK from my Arch Linux computer at home for a while. So that should be exciting. So we can hack around on some Linux tools, something that we haven't really had a chance to do in the past. And I am very excited to show everybody the over-engineered Arch Linux computer system that I built that I've been using for the past couple of years. So that'll be fun. A nice revamp of TGIK in my system. It'll be pretty exciting. Also, it's got a lot more resources, so we can actually have some fun with compiling things if we want to. Okay, so anyway, let's jump over here. And so every week, we do Welcome to TGIK, where I tell everyone hello, and then we also go through and we see what is new in the ecosystem for the week, and we just kind of look through some of these. I've gotten to the point where I don't even read these beforehand anymore. I just read them on the fly, and it's always exciting because they're surprising to me as well, and we can just learn about them together. So let's see, the first one here we have Introducing Kube IP Tables Taylor. Saeed says, are you leaving? Nope, not at all. Well, I mean, for the weekend, yeah, but no, I'm happy. Life's good. So anyway, introducing Kube IP Tables Taylor, better networking visibility in clusters, improved experience for app owners. Let's see what we got here. Process behind Kube IP Tables Taylor. Okay, so what's going on here? So we have a watcher, and it detects changes in configuration, and then it sends it out to the parser, and the parser filters it, parses it, and then sends it out to the poster. The poster then applies Kubernetes API to locate and summon events to pods. Okay, so this is just a way of mutating IP tables declaratively, which is exciting because a lot of the CNI providers that we've looked at do a lot with IP tables and setting up your route table on your system. That's how the pod networks are built. So I think this is sort of a declarative way of defining what you want your IP tables to look like, and this will enforce them over time, which is, as we learned with Kubernetes, is a much more resilient pattern for folks. Oh, and Nicholas is here. So Nicholas is going to come on in. Come on in, Nicholas.
It's me.
I love when you come and visit me every week.
The weekly beer fairy
Yay!
is here.
What'd you get this week?
I got
Amber?
Immersion Amber
Nice.
from a Seattle company.
So, Nicholas, do you have anything going on this afternoon?
Why, yes, I do. Thank you for asking in a very organic manner.
Okay, great.
We're doing the Cloud Native Social Hour in an hour.
Fantastic. What time does that start at?
It starts at 2.
2 p.m. Pacific.
Perfect. So this time we're doing chaos engineering. I think it'll be a lot of fun.
Oh, that's cool. I know a lot of folks have been talking about that.
Yeah, and so that's coming. It's been coming up in my mind a lot, and so I'm like, this week we're gonna do it.
Are you just gonna break a bunch of stuff, or what are y'all gonna do?
I think for the most part we're just gonna talk about it.
Okay.
The demo that I set up isn't exactly as breaky as I want it to be, but I also didn't have a lot of time. So.
Okay. Well, if you need something to break, I'm happy to come join the call and break stuff.
Yes, please. Just like throw a chair out a window, like chaos.
Yeah. All right.
All right. Thank you.
Thanks, Nicholas.
Cheers.
Bye. That's my colleague and good friend Nicholas, who works here in Seattle with me, and he likes to bring me presents and come and talk about his happy hour that he does every Friday afternoon after TGIK, that if you want to join, you certainly can join. And we can get a link and drop that in the chat if there isn't one already. So let's see what folks are saying. Saeed says, because you said you were doing TGIK from home in the future. Oh, yeah, no, we're just getting a different office. So this office is shutting down. So while we're waiting for the new studio to get built, at the other office up here in Washington, Joe and I will be doing TGIK from home for a couple of months. But yeah, I'm just gonna be working from home for a while is all that boils down to. Sean says, hey, from across the street. Christian says, service. And Brian says, hi from Denmark. And it looks like we have somebody from Belgium and Eric from Seattle. Good to see everyone. Hello from Tokyo, Japan. Hi, Conrad. Thanks for joining. And hello from Tokyo, Japan. Okay, so yeah, it'll watch changes on IP tables log files, it'll parse IP tables, and then locate pods and send out events. So this is just a really interesting service for managing IP tables, which we do a lot in Kubernetes, specifically with our CNI implementations. I think pretty much everyone, except for Cilium, uses IP tables to some degree. So we do a lot of mutation there, and sometimes these IP table rules can get extremely complex, and there can be a lot of them as our networks start to get more and more complex, and having a tool like this would simplify the problem of needing to mutate your rules and actually make configuration changes. Okay, so that's the IP tables Taylor. Next up, we have DevCube, bootstrap K8s clusters with custom binaries. Oh, this would be exciting. So you can bring your own binaries to the table and build a Kubernetes cluster from scratch. Okay, so yeah, this is totally Linux from scratch, but for Kubernetes. So yeah, let's see somebody. Hello from Paris. Good to see you. Sean Smith said, yeah, we've had to move to Cilium for some stuff because it doesn't use IP tables. Cilium is an awesome CNI provider. If you haven't checked out the TGIK I did on Cilium, I strongly suggest checking it out. It's really exciting stuff, really cool tool, and they did a really good job with it. Okay, so DevCube. Currently, a lot of Kubernetes bootstrappers are black boxes who don't provide a lot of flexibility on how the cluster is set up. Not Cubicorn, because I explicitly called that out when I was designing it. DevCube changes that. Based off of Kelsey's Kubernetes the hard way, it wires together a cluster with custom binaries. Ooh, that's a cluster with custom binaries. That's hard to say. Complete with flannel and core DNS, which we all know is the new preferred DNS that I think came out 1 or 2 Kubernetes versions ago. We switched over and started using it officially. So I think the attraction here is you could say, I want to make a change to the API server. Whatever, maybe you need to flip a bit, or there's a constant that you need to change its value to, or you want to change some setting in there that's hard-coded. And then you want to be able to run a Kubernetes cluster with your specifically unique copy of the API server or the controller or the scheduler or whatever. You would be able to glue a cluster together using custom pieces and maybe conventional non-custom pieces as well. So that's what DevCube helps you do. So this looks exciting. I know a lot of people who work on Kubernetes who this has been a problem for, specifically for us here as we were working at building out our version of Kubernetes. Having something that we could spin up Kubernetes easily with our own custom binaries would have been really helpful. I think we're using Kubicorn right now to do that. But this is another tool. Notice it says no kubeadmin. So I think this is pretty exciting. Okay. Actually, real quick, while we're here, I wonder, does this do infrastructure too, or is this just like kubeadmin where it just starts the custom binaries? Use custom binaries for each component, change the flags, add new nodes, yeah, create the VM. Okay, so it does mutate infrastructure as well. Okay, that's exciting. So it does a little bit more than what kubeadmin does. Okay, so next up we have Kubernetes Identity Management Authentication. Kubernetes Identity Management Authentication. Have you deployed Kubernetes, but now you're going to get in the hands of your developer and admins securely? Kubernetes has taken the world by storm in just a few years, has gone from an interesting project to a driver for technology and innovation. I'm still confused what this thing does. It says the first thing to ask is, what is an identity? In K8s is very different than most other systems. It's a set of APIs, no web services. Okay, I think this is just talking about service accounts, attaching a service account to a pod. Looks like it explains kind of what RBAC is. Okay, so there's an OpenID Connect primer. Okay, so this is gluing together OpenID with the Kubernetes auth system that is already in place. So Kubernetes has a basic authentication system that we call RBAC for role-based access control. And I think this just maps an existing auth system down to the Kubernetes one. Let's see, Christine here says, that's a great article, the IDM one. Is that this one? Are we looking at the IDM one? Yeah, I guess. I don't know. Anyway, if you want to read more about Kubernetes identity management, this is a good article here. And I think Christian is alluding to the fact that they also enjoyed this article. So come check it out. Load balancing strategies in Kubernetes. So this sounds exciting. L4 round-robin load balancing with kube proxy. Okay, so what we have here, we have kube proxy that does a round-robin load balancing, which round-robin basically says if we have 5 things, we just go in a circle and repeat ourselves. So we'll distribute our load. We'll send one request here, the next request here, the next request here, the next request here, then here, and then just start that cycle over again and just repeat that indefinitely. And that's what round-robin means. It just goes around in a circle. So that's how that load balancing works. And there's different algorithms that do different things and like are smart enough to spread your load in other ways as well. Round-robin's a pretty effective and extremely simple one, which is why I think a lot of folks like it. So anyway, it says in a typical Kubernetes cluster, requests that are sent to the Kubernetes service are routed by a component named kubeproxy. Somewhat confusingly, kubeproxy isn't a proxy in the classic sense. That's one of my favorite parts of it. But a process that implements a virtual IP for the service IP tables rules. There are those IP tables rules again. Let's zoom forward. Moreover, it routes at L4 TCP. So there's different layers of how high or how low on the network you can go, and that's where you get L4 versus L7 round-robin load balancing with a tool like kubeproxy. So now let's go down here to L7. What if you're using a multiplexed keep alive protocol like gRPC or HTTP2? So multiplexed in this example just meaning it can do both ways communication. You can send and you can send back up to it, and you can send messages to it and vice versa. Okay, so you can use API gateway for Kubernetes, such as Ambassador, and you can bypass kubeproxy altogether. Okay, so this is just talking about the differences between L4 and L7 load balancing, and a couple of tools down here at the end, like maglev, or that's the algorithm that we would use for load balancing, and ring hash is another one here. And it talks about the differences and the different algorithms you could implement and which tools make good examples of things that you can get up and running to do various types of load balancing in Kubernetes. So if load balancing is a concern of yours, you want to learn more about the hashing algorithms and the way we distribute traffic, come check this article out, and it should be able to give you a pretty good head start on understanding this stuff and figuring out which of these various combinations are going to be right for you and your team. Okay, the Talis folks are working on Talis Cluster API integration. We are looking for feedback. This sounds exciting. I don't even know what Talis is. And we're on Reddit. How did this happen? we started working on Cluster API provider for Talis a few weeks back. So I think everybody here has probably heard me do, this is Talis, but I think everybody here has heard my rant on Cluster API at least once. If anybody wants me to go on my rant again, feel free to drop a note in the chat, and I'm happy to explain what Cluster API is. But just in case, I'm going to make an assumption that folks here already kind of have an idea of what Cluster API is. So anyway, this says a modern operating system for Kubernetes. What on earth does that mean? Talis is a modern operating system for Kubernetes that provides a number of capabilities. A few are security, predictability, and evolvability. Features: it uses muscle libc, it's written in Go, it uses gRPC, it runs containerd, and it uses kubeadmin to bootstrap clusters. It's secure, it's minimal. Examples: OS Cuddle PS. Oh, interesting. Okay, so it looks like it's a tool. Okay, Eric wants to hear the rant. Okay, I'll go on the rant here just in 1 second. It looks like this is a tool that you can install on top of Kubernetes, and it has some built-in primitives that are very similar to like an operating system type scheduling environment. And it looks like here we have various images, and they have PIDs. So I'm assuming whatever is scheduling these things on this operating system behaves similarly to the way that the Linux kernel schedules work. Okay, so Lamati says, I learn a ton every time you rant. Okay, I'll do my rant. Okay, so a long time ago in a galaxy far away, actually I can pull this up. Let's do it up here. Let's see. So we want to do cops rest server Kris Nova. So I was working on cops a long time ago. And one of the ideas we had that I was like, why don't we expose our API over HTTPS? And this is like before we even had aggregated API servers in Kubernetes. So yeah, this was 2016 when I brought this up. And I was like, hey, why don't we give our API that we use for cops, and why don't we give that thing like a REST endpoint, and that way folks can interact with it systematically, and we can start to sort of build out this cluster management service using cops as our base for it. So we kind of talked more about it. We thought it was a good idea. The idea kind of stuck, but we never really finished it, and it kind of just got kicked to the side, especially as things like third-party resources came to play, and then ultimately CRDs and the aggregated API server. So anyway, this is a conversation we had, and you can see this got closed in 2018. But this was sort of how the whole idea of Cluster API, we first started talking about it, and we kind of haven't stopped talking about it since we originally brought this up. And so I think probably the best resource to learn about Cluster API is if you go to Heptio Cluster API, right here. This is like a state of the world. It's a blog I wrote last year that sort of explains like how everything came to be in a lot of detail, but I'll kind of just give you the high-level overview, what you need to know here. So there was a lot of folks looking at this idea of having an API for a cluster management service. We have a tool, there's one called Archon. Let's see here, Archon, let's do Kubernetes. Qbert Archon, or Archon, however you want to pronounce it. This kind of does like an API built into Kubernetes that you can interact with, and will actually go and like create a cluster for you or whatever. There's some folks at a company called Lutzi, I think I said that correctly, who had built a similar tool, and some folks at Google were also interested in it as well. And so following up on my book, Cloud Native Infrastructure, a handful of us got together and we kicked off an email to, let's do SIG cluster lifecycle, cluster API. And we kicked off an email. I don't know if we'll be able to find it or not. Somewhere. It's in the Google group if you want to go do the SIG cluster lifecycle history here. And we were like, hey, let's come together and let's put together an official API for what infrastructure looks like in a cluster, lifecycle, Google group. And we can start to define this as a community, and then we can start building out common libraries that we can use. And we have a standardized way of shaping what our cluster should, like how we would describe our cluster. And then we could have various controllers that read that shape and then go through and reconcile it for us. And so that's Cluster API in a, Lotzi actually got KubeVirt support for the Cluster API. Awesome, thanks for sharing that, Fabian. So in here, I think we can do cluster API, see what comes up. I don't know if we'll be able to find it, but it's in here somewhere. What is cluster API, roadmap, next steps? Yeah, you can come through and you can look at this stuff if you want. Anyway, it's just an email to the SIG. It's not a big deal. So that's Kubernetes cluster API. So anyway, we're going to go back to, not DevCube, we want Talis here. And if you look, it says, let's go back to our article. We started working on a cluster API provider. So what that means is I'm going to go to my screen over here. See .cam. Wait, oh, my .cam's not plugged in. Let me plug this thing in. See if we can get this to work. Perfect. Oh, and y'all get to see my M&Ms that I'm eating. Okay, so we have a standardized API shape. And the first thing we have is we have the cluster itself, or like the control plane components. So we call this one cluster. And then we have some subset of things that we call machines. And each machine can be in a machine group, or it can just be a machine and basically behaves just like deployments in pods. Or I think it's a machine set is what it's called. So anyway, this would define something like what port is my API server listening on? Or what flags are we going to use to configure our scheduler? There's going to be various things that we would configure here. And then maybe on this one we have an EC2 large, a medium, and this one is, for whatever reason, running CentOS instead of Ubuntu. And we can define what we want our infrastructure to look like. We then would have a controller that would read this and kick off a control loop, which we'll kind of draw like this, and reconcile that against some cloud of your choosing. In this case, that cloud is going to be Talis. So in other words, you're going to be able to use the same standardized way of defining what you want your cluster to look like, and then they're going to have some reconciler down here that brings that to life and keeps that happy over time. Okay, so that's what's going on here with cluster API. So those first 6 words that we saw over here actually said quite a bit about what's actually going on here. So right now it's still a work in progress, but we are hoping to get the Kubernetes community involved to help shape how cluster management with Talis and cluster API will look. So you can look here, they have cluster API provider. And what's great about this is if you go to the cluster API repository, there's tools here that will help you bootstrap a brand new implementation or a brand new provider. So you can come through, you can read about how we have different CRDs, you can get involved. You can see there's one for vSphere. We got one for AWS that we've been working on. There's one for Azure. There's one for DigitalOcean. I think Marco did that one. There's one for GCE. And the beauty of all this is you define your cluster in a standardized way regardless of where it's running. So we're starting to get a lot of that multi-cloud and multi-faceted abstractions that Kubernetes is so famous for having. So anyway, that's Talis with cluster API. So next we have K8s 1.12.8, which this is an older version of Kubernetes, but it's a newer, older version of Kubernetes, if that makes sense. We're on 1.14 now, but we do still keep up with some of these releases, and this is the 8th version. So we can go here and click on our changelog. We all know I like to read the changelog, and we can actually see connections from pods to services with 0 endpoints will now ICMP reject immediately, so that means you won't be able to ping them, rather than black hole and timeout. And it looks like Tim did that one. So yeah, you can come through and you can see what all has changed, and if you want to keep running 1.12, probably a good idea to upgrade to 1.12.7 here. So that's exciting. Good job, release team, for keeping Kubernetes happy and working towards a better reality for tomorrow there. Let's see, let's get some water. Check out this bot for some nifty K8s Slack notification integration. Yay, who doesn't love a good bot? Add that app that helps you monitor your Kubernetes cluster, debug critical deployments, and give you recommendations for standard practices. It's called BotCube, and there's a nice big juicy add to Slack button here, and it looks like you can install it. And I guess this is sort of like chat ops, but for Kubernetes, if you want to think about it that way. Sort of giving you an interface that you can use in Slack so the rest of your team can see, for you to do things like configure or debug your cluster or schedule work or something. Will it handle network and storage based on what environment it will create the cluster on, e.g. load balancer in GCP and AWS? So Waleed, that's a great question. So I think what Waleed is asking here is, will the cluster API handle network and storage? So yeah, it does go through and define some of that information. I think the scope of work for cluster API is the Kubernetes layer of software, and then the infrastructure that is actually running that Kubernetes layer of software. After all of that has been reconciled and is happy, Cluster API has no more concerns. So actually getting work scheduled on Kubernetes cluster is a completely out of scope thing, but making sure your cluster is happy and your network is happy, we can do that declaratively now, or at least that's the goal of Cluster API. Hopefully that answers your question, Waleed. Okay, so yeah, there's a cool bot. You can use it to play with Kubernetes from Slack. If you're interested, check it out there. Simplify Kubernetes RBAC in Amazon EKS with the open source Pulumi packages. So a little bit of prior art here. The way that EKS works in Amazon, they have their own CNI provider that uses the VPC by default. It's something that SIG AWS and Amazon have been working on. SIG AWS, EKS, CNI. Let's see if we can find it. Support Amazon ENI CNI plugin. So yeah, this is the plugin here. I think you can actually go and find the repo if you want to Google around for it. I don't know if I'm really going to dig that deep for it. This might be it. Cluster API, AWS feature set. Yeah, so this is talking about how it uses the VPC. And so it doesn't use a traditional CNI tool that we would see in like another type of Kubernetes cluster. Amazon actually went and built their own specifically for Amazon. So let's go back, and it says simplify Kubernetes RBAC in Amazon EKS with open source Pulumi packages. So again, RBAC is our authentication method, and EKS is Amazon's managed Kubernetes that runs its own in-house specific, domain-specific CNI. Oh, and this was written by our friend Nishi, who's a friend of mine in open source, and one of the other chairs on SIG AWS. And she does a lot of work for SIG AWS. She's probably the most active one of us all right now. So hats off to you, Nishi, for doing all that you do. So if you want to come in here, you can see how we can get Pulumi installed. We can create 3 IAM roles with trust policy to map to Amazon's EKS RBAC. Okay, so getting Amazon and IAM, so Amazon's IAM to sync with Kubernetes is an interesting problem that's been around for a while. We had tools like Kube to IAM, and then we wrote some tooling here at Heptio to help with this. And it looks like Pulumi also is going to concern itself with some AWS roles and mapping those back to Kubernetes RBAC. So this is pretty cool. If you're interested in this and learning more, come check it out. This is going to be of use to anybody who's seriously considering running a production EKS cluster in the near future. I would strongly suggest you come through and read this and evaluate this tool, and maybe we can do a TGIK on this in the future if folks think that would be a good idea. Okay, we're almost done, I promise, and then we're going to start working on Qbert. Okay, announcing LinkerD 2.3 towards zero-touch, no-trust networks and Kubernetes. So we got a new LinkerD release. And it's just moving towards this simplicity model where you just kind of set it and forget it, and it comes through and secures your cluster and hardened your cluster. So you can come read more about it here, and you can see how to install it. Don't ever do this, please. Don't curl pipe to bash. But you are more than welcome to get this file and then open it up, see what it contains, and if it looks good, then you can go ahead and run it. But that's how you would install LinkerD on your cluster, which is exciting. So if you want to come find out more, come and check it out here. All right, and on that note, let's move over and let's talk about KubeVirt. So I'll do another rant. This one's just for you, Lamati. Okay, so over the past probably month or so, I've been giving a lot of talks about the different kernel set features that support virtualization and comparing those to what we use to create containers. I've been doing a lot of research on how virtualization works, how the kernel does the translation from kernel to kernel, how we create a new synthetic virtual kernel on top of a hypervisor, what that means, what that looks like, and I actually went and wrote some KVM code in C and was able to spin up a very, very rudimentary hypervisor as I was learning about virtualization. So without going into too much of a rant, you can go watch my talks if you want to find out more about it. We're going to be exploring how we're using Kubernetes to manage and mutate VMs in the cloud using a tool called KubeVirt. And we can actually pull up the docs here. Qbert IO. So again, we see this pattern of we go and we declare something, and then we have some sort of reconciler that will read that declaration, audit the state of the world, detect that it's not running, and go and bring that to life so that it is running and so that we are in a state of reconciliation. And this is Kubernetes. This is the core of Kubernetes. This is why Kubernetes has been so successful. It's because of this pattern, the same one that we saw. Let's go over here, where we had various configurations, and then we came through and we had an event loop that would reconcile that up against something else. So in this case, what we're doing with KubeVirt is almost the exact same thing. My diagram is going to look almost exactly the same. We are defining a virtual machine this time, and this is just YAML here. So when I draw these squares, just think to yourself, this is just like several lines of YAML, and we're actually going to look at one of these concretely in just a second. And then we have, here's our arrow again, and then we have our reconciler or controller or operator, depending on how specific this bit is. We would call this a different name based on if this is domain specific or not. And this would just run over and over and over again until the end of time, and that would sort of do this audit and reconcile what we actually wanted to be there. So in this case, if we defined, let's say we wanted an Ubuntu server, we wanted it to be a small, we want maybe, let's say 50 gigabytes disk, maybe we want 4 gigs of RAM, whatever. And you would go through and you would define all of this in your YAML here. And that would just look like, operating system is equal to Ubuntu, right? And then this would run, and it would say, okay, we need to make sure that we have a small Ubuntu server with 50 gigabytes of storage and 4 gigs of RAM running in EC2. I don't see any servers running in EC2. I better go create one. And that's what this loop here would do. And that would actually go up against some public cloud, like EC2. And if you look on the KubeVirt homepage, let's flip back over, you can see it, you can do it on Minikube, you can run it on Amazon, or you can run it on GCP. KubeVirt is expecting KVM. I think it's KVM for now. Just had $1 million idea, fruits but M&M sized. Let's see, Lamati had a question. Let's see what Lamati said. Lamati said, which virtual machine VMMs does it work with? Firecracker, Kata containers, KVM, all of the above? Yeah, I think KVM is going to be our winner here, Lamati. I think if you look at what Fabian and Christian say, that's accurate. Firecracker and Kata also usually build upon KVM. So yeah, if Fabian is correct, I'm 99% sure that Firecracker actually is just a KVM implementation. So factoid about KVM. It's a Linux package, so you can actually go and install this on a Linux-like system. It supports virtualization, which a lot of folks don't realize about virtualization is that's dependent on your hardware. So if you don't have hardware that supports virtualization, installing a package like KVM on your Linux computer is effectively not going to do very much. And furthermore, KVM is only available on Linux. So this was an interesting challenge for today when it came through, and I was running my Mac OS X operating system, and I was looking at how we were going to demo Qbert, and we'll talk a little bit. Actually, we can just jump into it right now, and we can talk about my story of what I tried, what I was able to get working, and what I was not able to get working. Yeah, and it looks like, David, I'm going to approve your comment here. It says KubeVirt uses KVM. Okay, so first things first, don't use these. That's the first thing you want to tell yourself. Or actually, on Friday, what's today? April 26, 2019, don't use these. I was running into some trouble earlier. I think they just have to make a small change, and they'll be back up and running again. But these are pretty simplified examples of how we would install KubeVirt if they didn't have a bug in them right now. So what you would do is you would come here, you would click on an AMI, It would take you to Amazon or GKE, depending whichever one you were in, and it takes you right here to the creation screen, and you can like go through and configure instance details and add storage, and you can see here's our 8 gigabytes, yada yada yada. And this is just our our foundational Kubernetes cluster. So we need a cluster to run the software on to create other virtual machines. So it's just like the chicken and egg problem that we solved with Cluster API, where you need to have some infrastructure in place on day one before you can start creating other infrastructure as well. And Saeed says, Christian, my bad. And Fabian says, those buttons should be working by now again. Oh, okay, so we already got them fixed. So Fabian, awesome. Let's actually try to do one of these. So yeah, we want 8 gigs here, no tags, port 22 so we can SSH into this thing, review and launch, but the only thing we want to change is, if you read the documentation, and this just takes a while, so I'm going to kick it off now, but we'll look at the docs here in a second. It says you need at least 4 gigs of memory. I'll go do one better than that, and I'll go ahead and, yes, I want to continue with this instance, type 2 too large, next. Okay, so let's launch this. I'll go ahead and spin this up now, and we can talk about the documentation and what's going on while this is coming up in the background and see if we can't try this out. We also have another approach that we're going to try as well. So let's just go and let's just like familiarize ourselves with the documentation for KubeVirt really quick and just kind of get an idea of what we're going to be doing today and what we're going to be playing with. So if we go down here, there is a docs section, and it says an easy-to-use demo. And this is what I want to actually run through today, is this KubeVirt demo here. And this goes through, and it tells you how to do it on Minikube. But we also discovered, and again, hats off to Fabian for helping me with this, we also discovered we could effectively replace this Minikube steps with a GKE cluster, and we were able to get libvirt up and running. So you can see here, I've already got a GKE cluster, and if I do my oh so familiar kdump command, you can see that it's just a very primitive GKE cluster. Like it's got Prometheus and Heapster and the metric server up and running in kubedns, but it doesn't really have any other namespaces or any proprietary software running on it yet. So that's where we are and what we have going on. And then here in Amazon, we'll go here, and you can see that this thing is initializing now, and this takes about 10 or 15 minutes to come up, so that's why I wanted to get it started. Okay, so the KubeVirt demo. Let's skip past this, and let's look at creating virtual machines. Introductions. Okay, so this is what I wanted to show folks. If you come through and you find, I'll actually add this to our doc here. Let's do creating VMs, morale. Okay. You can actually come in here and you can see we have a virtual machine instance. So in Kubernetes, we can define these things called CRDs, or custom resource definitions. And a CRD is effectively one of these arbitrary objects that are important to humans. And the D part, the definition, is just the shape of this object. What fields does it have? In this case, we have fields like domain. We have fields like termination, grace period, seconds, and that just so happens in this example to be set to 30. You can see here we have devices and memory, and there's all of these lovely configuration bits that we can come in and change. And the beauty of a CRD is that you can make this look however you want. And you can define whatever fields there you want, and you can have your controller read those fields. And in the software that reconciles it, you can actually make it respect these fields. So it just gives you a framework for defining something in Kubernetes, and then a controller framework to get that reconciled and to get that running. And this is a huge win in Kubernetes. And this is a relatively new feature of Kubernetes that hasn't always been around, at least not always this in a simplified version. So Hepto says if you missed the notes URL, you can check it out here. So that's the hackmd. And this is how we would effectively define a virtual machine instance. And you can see it says note a full API reference is available here. And you can see today I think we're going to be trying to run v.0.16.1, but we can go ahead and pick out any version we want. So come through here, you can see there's a types definition, and this is the actual API, which is just that YAML object we just looked at. You can see that it's got API group list, categories, kind, namespace, singular name. Let's keep scrolling, affinity, bootloader, CPU. So yeah, you would be able to come through and like define like the amount of cores you want for your CPU for your virtual machine. So I guess it's probably now a good time to talk about why do we even want VMs in the first place? Why do we even want to reconcile a virtual machine with Kubernetes? With containers, we should have everything we need. Why are we using container scheduling software to spin up virtual machines? The use case is surprisingly pretty simple and probably even more surprisingly extremely common, which is, let's pretend you had a monolithic application that was running on a virtual machine. And over the past 4 years, you and your team have written maybe Ansible or Terraform or Puppet or Salt or something that would go and provision all of your servers for you so that your application would be happy. And let's just pretend you've got it down to a science. You click on your magic shell script and poof, you get a VM running in vSphere somewhere, and it starts to configure itself, and it installs all of those goodies and all of those packages and cats all of the right information out to all the files and rewrites some stuff in the Etsy directory, and it's just really awesome, and you always get a really happy server at the end. And then your application gets installed, and that's another 10 steps, and your application gets up and running, and it's working fine. We poke a hole in the firewall, we can hit the server, the database is up and running, and it's happy. I bet probably 80 or 90% of folks on TGIK right now, they're either in this situation or were not far from this situation in a very short time ago. So because of the way virtual machines work, if we had all of that work done, we could simply port that work over to a tool like KubeVirt, and it would actually be able to go and create a virtual machine for us. So that would allow us to adopt Kubernetes, get the resiliency of the Kubernetes scheduler to fix it if something ever goes wrong, and we can still keep our virtual machine as it stands today. Now, maybe after we migrate it over, we want to start looking at pulling it apart, maybe containerizing bits and pieces of it. We certainly can do that, but if we just need a very quick, light translation from virtual machine running in my data center to virtual machine running in Kubernetes, and that's all that our team wants to do right now, this is a tool that can help with that problem. Okay, so Saeed says, I remember something called virtual kubelet. Is KubeVirt related? Great question, and no, they are not. So the way virtual kubelet works, virtual kubelet effectively, let's see if I can't do a demo really quick. So if I come here and I do k run nginx -- image nginx, I can do a kget po, and you can see that this container creating status is happening. Now what's actually going on there is there's a tool, it's a statically linked Go binary that we call the kubelet. And the kubelet runs on each of our nodes. Like if we do kget nodes, we have 3 copies of the same program running on each of these. And it's not running as a container, it's just running as like a Linux service that systemd watches. And what that's doing is it's taking an instruction from the scheduler and the controller manager, and it's saying, hey, one of these servers needs to schedule this pod. So the kubelet on whichever server gets elected to schedule the pod is the thing that actually does effectively a Docker run for you on each of these computers. So what's cool about the virtual kubelet and kind of the idea behind it is to use a tool like Microsoft's ACI, or there's one for Amazon, it's called ECS, that allows you to basically run a container without any of the other configuration bits that you see with a tool like Kubernetes. Like it's very cut and dry and just says, run an Nginx container, expose port 80, and I want it to have 4 gigabytes of RAM, ready, go. And it just does that for you, and you can get a public address for it. And there's a lot of services out there that allow you to run containers like that. So all the virtual kubelet does is it basically hacks or spoofs the real kubelet So instead of running a container on one of these servers here, it would actually just vendor that out to one of these managed services in a cloud somewhere. And the beauty of it is you would be able to basically use the cloud service as your workhorses for Kubernetes, but you still get all the primitives and all of the built-in logic and features of Kubernetes. So that's what the virtual kubelet is. KubeVirt is a tool for managing virtual machines with Kubernetes. So big difference here. So yeah, let's see what folks are saying here. Fabian says, except for the string virt, not. Yeah, so Fabian's just agreeing with me. So those are the difference between the virtual kubelet and KubeVirt. I know it can be quite confusing, but if you want to think of the virtual kubelet, you can just think of something that has like a spoofed or a mimicked kubelet. And if you want to think of KubeVirt, you can think Kubernetes for virtual machines. Okay, so let's get back out of here, and let's go back here. This is a ranty episode. I usually don't get this ranty on TGIK, but I guess it's just a ranty kind of week. Okay, so anyway, you can come through and you can see we can set the clock, we can do config sources, we can do disk sources, DHCP. There's a lot of things that are configurable using this API for the KubeVirt here. Oh, here's a list over here on the right. And these are a lot of things that an operator or a systems administrator would concern themselves with if we were just running a traditional virtual machine. And I think that's kind of the point here, is we're starting to pull out and create APIs for these things that we maybe used to SSH into a server for and like do manually. We now can declare and use Kubernetes resiliency primitives to reconcile that state for us. Fabian says, nice explanation of the virtual kubelet. Thank you. That's why I make the big bucks. Okay, so let's jump in. Waleed says more ranting and digressing is good. Oh, if there's one thing I can do, it's rant and digress on TGIK. This is like my specialty. Okay, so anyway, let's look at this demo really quick and let's start running this. We're already 45 minutes into the episode, so I want to get kind of busy here. So if you see here, it says KubeVirt demo. So click on that. I'm going to eat an M&M really quick. We can start going through this demo. So the first thing it does is it sets up a cluster with Minikube. We're going to skip that because we're going to use GKE. So we can bypass this first part here. Let's look at the next thing we do. Kubectl create namespace KubeVirt. Let's grab this. Jump in our terminal. Create namespace KubeVirt. Oh, it already exists. Kget ns. Let's do this. K delete ns. It's still terminating. We might, because I deleted this 2 hours ago. I don't know why it's still terminating. Let's try this. Let's start exploring. So this is going to be me kind of just seeing what's going on with the cluster really quick and why this namespace hasn't terminated yet, because ideally we could just copy and paste these commands. But I ran through some of this earlier, and I deleted the namespace, and usually that deletes pretty quickly, and it deletes whatever resources are running in the namespace as well. But for some reason, it's been hanging here on terminating, so let's see if we can't figure out why. Fabian says, I actually wonder if it does work with Minikube even on Mac OS X if emulation is used. Okay, so what Fabian is alluding to here is this problem that we call nested virtualization. Here at VMware, we have solved a lot of the nested virtualization concerns with a couple of our tools, and we're a really big advocates of getting this sort of done correctly in a logical, meaningful way, and taking advantage of optimizing our systems as best as we can for nested virtualization. And all nested virtualization is, if you don't know what it is, don't freak out. It's totally just basically running a virtual machine in a virtual machine. That's all it is. So what Fabian is alluding to here is Kubernetes runs in a virtual machine whenever you use Minikube. If I was running Minikube, let's see, do I have VirtualBox installed? I do not. I would just do like a command like this. I would do Minikube start, and I would be able to go down to the bottom of my screen and click on the VirtualBox manager and see that it actually just started running a new virtual machine. And then I could SSH into that machine using a command like this. And then I would be able to actually see the VM that's running all of these wonderful Kubernetes components. Now with a tool like KubeVirt, it's kind of contradictory because the whole point of Qbert is to schedule secondary virtual machines. Well, if we're already running on a virtual machine, how are we going to run more virtual machines on that virtual machine? Virtual machine is officially losing all meaning to me right now. But that's what nested virtualization does, or emulating, as Fabian called it. So that's why that's a concern for us. So David says NS might be hanging because of a CR where the finalizer is stuck. I have a feeling that's what's going on, David, so we're going to check it out. So let's do our alias really quick. We'll do it alias KV for KubeVirt equals kubectl -- namespace KubeVirt. I cannot type today. Wow. Oh my gosh. KubeVirt. Somebody want to come type for me today? Okay, so now we can do kv get crd. Kv cr. Kv get cr. Let's see what folks are saying. David says namespace might be hanging because of a CR with a finalizer. John says, I've had it work on Mac and things like Virt CLT console were problematic. That was several months ago. Regarding KubeVirt on Minikube on Mac, and Fabian says, nice to know. Okay, so it looks like we've had some folks try it, and they've had some success with it as well. So let's just do kv get all, no resources found. Kv get PO, no resources found. K get NS. Terminating. Why is this still terminating? Can you explain this namespace? Maybe there's something in the logs. K explain namespace KubeVirt. Okay, well, you know what? We're just gonna run it in a different namespace. That's totally fine. So we'll just call our new namespace KV for short. So K create namespace KV. And then let's come down here, and this is a very important command. So kubectl create config map, namespace cube system, KubeVirt config from literal debug.use emulation equals true. So this is actually what's turning on that nested virtualization emulation that we just talked about. K get all minus in KubeVirt. K get all minus in KubeVirt. I'm pretty sure I already ran this. Yeah, no resources found. So yeah, I don't know what's going on. And we can just run it in a different namespace and take the easy way out here. Okay, so we want this running in kube system. This looks good. Let's go ahead and run this. Oh, and let's get rid of that. Bang. Already exists. Kubectl get config map. Is that what's going on? No, because this is running in kube system. Okay, so let's kubectl get config map. Config map namespace cube system. And we want to delete, what was it called? KubeVirt config. This one here. K delete config map namespace cube system, the name of our bam, and now we can install this one as such. Poof. Okay, there we are. Kubectl describe NS KubeVirt. K describe namespace KubeVirt. Status terminating, no resource quota, no resource limits, annotations. Yeah, not really seeing anything here. No resource quota. Have I seen that before? Okay. Please create the KubeVirt config in the namespace you'll be using. Okay, so Fabian says create it in the namespace you'll be using. Okay, that's what I thought, but we had it in kube system. So let's put this in the KV namespace. Thank you for your help, Fabian. Poof. Okay, so now we have KubeVirt config created, and for good measure, let's go ahead and remove This one, just as good practice, we want to keep things out of Cube system unless we absolutely need it. Our new namespace is KV. Okay, so folks are just talking. They're a few seconds behind me, so I'm just reading it out loud as we go here. Okay, so we enabled emulation, debug use emulation equals true. So next we want to export our version of KubeVirt that we want to use. So in this case, I said we're going to do 16.1. So let's do .16.1. And so yeah, instead of doing a kubectl apply, we're actually just going to look at this first so we can sort of see what's going on here and talk a little bit about it. So we'll wget this, and we're going to cat out KubeVirt operator.yaml, and we can look at it here. As I always say, it wouldn't be a TGIK unless we catted out some YAML. Okay, so here's where we're starting. Cat KubeVirt.yaml. So we define a namespace called KubeVirt. I don't think it's gonna work, but we'll see how this goes. Next, we define a custom resource definition. So the D here implies that we're just defining the shape of the object. A single implementation of this object would be a CR, a custom resource. But again, here we're just defining what fields it has. So we define a CRD, then we define a cluster role. David says, do the apply with the new namespace you created. Got it. Thanks, David. So we create a cluster role, which a cluster role is a slightly more broad scoped RBAC rule that we can use to do things like list our nodes and various resources that are at the cluster level and not at the namespace level in Kubernetes. So that's what we're creating here. We have a service account that's attached to that cluster role. We're defining a second cluster role. We have a lot of rules here. Let's see, we got service accounts. We can get, list, watch, create, update, delete, patch. Oh yeah, we're just opening the world up here. That's fine. Everything's fine. Okay, let's scroll down. So this is just defining all of the different things you can and cannot do with this newly created RBAC rule. As you can see, it's quite lengthy and defines a lot of the resources and what you can and can't do for them. That's one of the longest RBAC rules I've ever seen, to be honest. And then we have a cluster role binding, which we've talked about this a few times. A cluster role binding is effectively a bridge table for all of our relational database fans out there that attaches the cluster role to whatever service account or user you define for it. So it's sort of what does that mapping, and so you can have different users mapped to different things, and we can have intricate complexities here with how we do our RBAC. Last but not least, we have a deployment, which this is going to actually contain the operator itself. So let's see what we got here. It's called a Virt operator, scheduler alpha Kubernetes. It's critical, which is normal for an operator. It runs Virt operator -- port 8443. Sets our verbosity to 2. We're passing an operator image. And then you can see here we poke a hole in the container port, and we have a readiness probe, which all readiness probe does is just tell Kubernetes if our service is happy or not. So David says s namespace Qbert namespace kv/q. I think I can just do this, right? The operator installs the Qbert infrastructure. Oh, I'm on my computer where my Emacs is super messed up. Okay, let's see, name Qbert KV, that should do it. So k apply minus namespace KV KubeVirt operator.yaml. Hopefully this works. We'll see what it does. Minus F here. Go back. Namespace KV, and then minus F here. Oh, no, we gotta go through and change it. Okay, so let's do Emacs, KubeVirt, and let's search for, no, I don't want to install that. /q, not /. And so we can search for namespace here. Search namespace Qbert KV namespace KubeVirt, change that to KV. Okay, that should do it. All right, K, let's run our apply command again. Oh, we forgot our -f again. And we'll clear our screen, and that should do it. Error, the namespace for the provided object KubeVirt doesn't match the namespace KV. You must pass namespace KubeVirt to perform this operation. Let's try to find that one. Sorry, this is taking a while, y'all. My Emacs skills are not the best on this computer that I'm using because I don't have my full setup installed that I usually have because something's wrong with my eLisp right now. Lisp problems. Okay, namespace. KV, oh, there it is. Cool. All right, so now let's try to run this command again. Yay, okay, so that's what we want. So we've created everything we just looked at, our custom resource definition, our cluster role. The letter is getting clipped. Virt operator, so on and so forth. So now if we can do a kgetall namespace kv, you can see we actually have some resources running. So we have the virt operator, we have our namespace, and we have a replica set for it. So Fabian says yay. Okay, so let's go back here. And let's do kapply. Let's look at this file. So we'll download this one and we'll take a look at it as well. So remember earlier I mentioned CR is a custom resource, so that's what we're going to be installing here. So I bet if we kget cr, kget crg? Huh, interesting. Anyway, wget poof, download that. Let's what was the name of that file? KubeVirtCR.yaml. So let's cat out KubeVirtCR.yaml. Oh, this is the world's simplest YAML file. So we just define KubeVirt and set it to KubeVirt and only pull the image if it's not present. Was the operator in error state? Let's just check and see. Nope, not namespace. KV. Crash loop back off. Good eye. Who found that one? David says the CR needs to go into the new KV namespace. Okay, so yeah, let's edit this CR here. KubeVirtCR.yaml. And namespace. Bam. Cool. So let's apply this now. K apply minus name KubeVirt -f KubeVirtCR.yaml. Okay, so now let's see if that fixed our operator. Once it restarts, we should be able to see. I'm gonna pop open this beer. It's after 2. Thank you, Nicholas. Stolen crash loop back off. So we can describe this and see what's going on. K describe. This might give us a clue to why that namespace didn't delete too. There might be something wrong with our cluster. Namespace kv poof. Oh. There we go. Let's see. It pulled the image. It created it. Back off restarting failed. Removing container. The CR won't take effect until the operator isn't in error. So what's going on with our operator here? Crash loop back off. Interesting. Describe PO. That's what I just did. Running it again, container image, index.docker, operator already present, so that's good. I don't really see anything. Gage wants me to look at the logs, so I can look at the logs. Kget PO, namespace KV, K logs, namespace KV minus F. Here we go. Logging before flag pars. If I had a nickel every time I got a logging before flag pars go error. Yeah, need logs. Unable to retrieve the complete list of server APIs, sub-resources, KubeVirt Alpha 3 is the server is currently unable to handle the request. I think there's something wrong with this cluster. I think that's what's going on here. K, delete, deploy, nginx. Because that was able to schedule fine. K, get namespace. She says, I am from the past. Okay, so honestly, let's do this. Let's jump over and let's see how this thing is doing. Because if this one's up and running, we can just finish up our tutorial there. And it'll be pretty quick and easy for us to get back to the same place we were. So to do that, we SSH CentOS at our public IP address. Yes. Oh, it's my SSH key. I downloaded a different one because we're in a weird region. So SSH Nova East there. That's what we want. Fabian says probably just some finalizers remaining. Fabian says, yeah, AWS sounds like a nice idea. Permission denied. Is it CentOS? Did I do that right? Did I copy my IP address right? Public IP. Launch Wizard 2, where's our key pair? Yeah, key pair name, Nova East. That's what we just used. Interesting. But at least the SSH server is up and running. Let's try to paste this IP and see if maybe I just typed it wrong. Come on, Nova, you know better. There we go. Alrighty, this should do it. Yay! Yay, and we have Kubernetes 1.14. Okay, I think this one's gonna work. Yay, good job, Fabian, for fixing this for us. Thank you so much. Okay, so let's now alias K is equal to kubectl, K get PO, no resources found. All right. Okay, now we're happy pandas. Let's go back here. We've already looked at the YAML, so we don't need to do it again. Let's export our version and then just really quick install these couple of commands. And in fact, let's just do kget all -- all namespaces. See what we have up and running. Okay, so it's already installed. Okay, so this is cool. So the AWS image that we installed through the AWS installer here comes preloaded with everything ready to go. But just in case that wasn't the case, we would have been able to come in and run these commands and effectively get us to where we want to go. The next thing we want to do is we want to install virtctl, which I'm assuming this is already also installed. Let's see. We have virt what? But I don't think we have virtctl. No. Okay, so let's do this command. And this is going to install the command line tool virtctl, which is what we're going to use to interact with our operator and our CRs and stuff with. So we are installing that. And we want to chmod it and drop it off in our path. So let's do this. Chmod plus x virtctl and move virtctl to user local bin virtctl. Okay, sudo bang bang. Okay, so at least now, oh, maybe not. So somebody was saying to use this one. virtctl here. Kudos to Pep and Rich. Pep says, yeah, it's there. Virtcuddle. Pep, what directory is this in? Is it in KubeVirt Ansible here? There's a make file. I don't see Virtcuddle anywhere. Line 1, not command, not found. Not the, what? Let's rmrf user local ben virtcuddle. I don't know why this is being so difficult today, but whatever. We can just do some hacking. And let's try this thing again. Okay. And chmod. The URL you asked passed didn't contain the version number, and thus virtcuddle is not downloaded. That makes sense. rmrf virtcuddle, because I didn't export this thing. Okay. Thank you all for helping me. This is why I like doing TGIK. 16.1. Poof. So then let's do our download command. Oh, this is taking much longer. Very good. Okay. Ah, my chat is blowing up. Let's see. You has moved the file to bin A. Virtcuddle was in your local directory until it was overwritten by the wget you did. I'm sure the curl command overwritten the existing file, moved it to user local bin. Oh, nice catch, Fabian. Yep. Okay, so let's chmod this. Chmod plus x. Virtcuddle. And we'll move virtcuddle into our path. User local bin virtctl. Bam. Okay, so now we should be able to run virtctl. Poof. Yay. Okay, next step in our documentation here. In virtctl, and here's where we're actually going to create a virtual machine. This is the moment we've all been waiting for. So let's take a gander at this YAML here. So to do that, let's just go back to our home directory. And we're going to, do we have wget installed? We do. So let's download this and let's cat this out and look at it. Wait, what was this file named? vm.yaml. Okay, so cat vm.yaml. Lovely. So here we have this lovely virtual machine CR that we're about to upload to our Kubernetes server here. And if you remember earlier when we did this, we talked about how we were going to be defining the VM, and it was just going to be little bits of YAML. Well, that's concretely what we're exactly looking at right now, which is we're defining the VM called virtual machine, and here's some YAML. Okay, so we tell it it's it's a test VM. We define some disks. Looks like we tell it how we want 64 megs of memory. We can define network information, volume information. Looks like we have some configuration-y bits down here. For all intents and purposes, I think this is a fine starting point. I don't see anything wrong here. I mean, we are running third-party software to begin with, so there's some inherent danger there, but for our demo, I think it's safe to go ahead and just go ahead and apply this. So apply -f vm.yaml. Okay, so we created our declaration of a virtual machine. So now we can do kubectl get VMs, and we can do oyaml test VM. So let's just do this. So now we can list VMs. Running is equal to false, and then it says we want an oyaml test VM. And what oyaml means is the output is in YAML, and then we just pass in the name, so it pulls down the YAML for this one instance. And you can see this is almost the exact same YAML that we just looked at a second ago, but now it's got some other information up here at the top that Kubernetes uses for various things. Okay, so we can install a VM declaratively, we can get them, and then it says to start a VM, you can use virtcuddle start test VM. So let's go ahead and let's run this. Virtcuddle start test VM. VM test VM was scheduled to start. And then we can do get VMIs, a virtual machine instance. Okay, so this is where we get into the same pattern of like CRs and how they relate to CRDs. A VM declares the virtual machine spec, and then you can have one or more instances of that spec. And that's the difference between a VMI and a VM here. So now we can do get VMIs, and that's why we had to run virtctl start test VM down here. So let's get VMIs. You can see test VM is in the stage scheduling. And then we can get OYAML here. Okay, and you can see here it's a single concrete implementation of that spec that we looked at earlier. So now my question here is, I am not a huge KVM user. What's the best way to inspect or gain access to this virtual machine? Do folks know how we would look and see what's running in KVM? You can also have running in your spec set to true as well, correct? You can also have running in your spec. Yeah, I think what Gage is saying, you can just flip the bit from running to true, and it'll automatically do that start test VM command here that we had to manually type in, which is handy to know. And it says accessing VMs. This is what I was just asking about. Virtctl console test VM. So, okay, so virtctl is actually a pretty handy tool. I like it. Virtctl console test VM. Successfully connected to the test VM console. The escape sequence is that. Log into Cirrus using default password go cubs go. Use sudo for root. Test VM login. So I think we do Cirrus. Password is go cubs go. So I guess now would be a bad time to mention that I'm from St. Louis. That's where I went to high school. Go Cards. Incorrect login. That's what I get for being a Cardinals fan. Test VM. Let's see. CEIRROS. Go Cardinals go. Yay, there we go. And then can we run bash? Nope, but we are in just a regular old shell. Okay, so let's see what we got going on here. Okay, super small file system. BusyBox multi-call binary uses free. Oh, it doesn't have human readable, so we can do free -m. A very small amount of memory. What else do folks want to see? Here's our thing. Here's top. We're using 8% of our CPU. We have a very small buffer up here. 99% idle. This computer is effectively doing nothing. This is a very happy virtual machine. So we can get out of this, and we can exit. And what's cool is, wait, there we go. If I come here and I do a df -h, you can see we have much more resources available to us, so that we were able to demonstrate we were actually running in a virtual machine there. So that's pretty rad. KVM working really nice, virtctl being a really nice wrapper that allows us to take advantage of some of the features of KVM, and we get to do all of that declaratively in Kubernetes with KubeVirt here. And then here are some next steps on setting up Minikube and so on and so forth. Now, we're getting close to the end of the episode here, so does anybody have any questions, or do they want to see anything else, or have I given folks a pretty good idea of what's going on with KubeVirt and how everything is going to be working? If I have everything set up, if you want to run it, go for it. If not, I'm happy to just tinker around at it. Maybe we can run virtctl and see if there's any other commands that look exciting. Let's do that. Good question here. Ashish says, what's the network setup look like? So you can start a VNC connection to the virtual machine. I wonder if that'll work. Remote viewer. Okay, yeah. It's not. I don't think the remote viewer is installed on this. So yeah, what was our console command earlier? Here. Cirrus go Cardinals go. Nope. There we go. I don't know why it always takes 2 times. So what specifically do you want to see about the network here? Looks like we have one Ethernet interface configured. Let's see, what operating system is this? Uname minus A. So it's Linux Ubuntu, so I bet we can cat etc. Oh, what is it? Network, interfaces, configure loopback, and the world's simplest ethos set up in the world. Very, very primitive networking here. Let's see what folks are saying in chat. It says, well, without any additional networks defined, you can attach the VM to the pod network. Oh, okay, so that's really handy to know. So we can actually create the virtual machine on the pod network so that we would be able to interface an arbitrary pod with our VM. So let's say maybe this is running a database and we want to be able to access that database. We would be able to use KubeVirt to get this on the same network as our pods, and we can have various pods in Kubernetes all happily running in the same network. And live migration. Is there an equivalent for an HPA for VMs to autoscale them in live migration? Fabian says, not to forget about live migration indeed. Yeah, Fabian, can you give us any more pointers on how KubeVirt would handle a live system migration or mutating the existing system? Like if I wanted to say add more let's actually try this, right? Let's try to add more storage to our declaration here. Oh, and let's see what happens. So do we have our df minus h command up here somewhere? Yeah, okay. No, that's this one. So let's access this again. Okay, so we want to save this command. So we have 18 megs of disk space here, and we have 30 megs mounted in root. So we can just remember 30 megs here. Okay, so let's you got to do this control character again. Okay, so let's exit here. Let's kubectl edit VM I test VM namespace KubeVirt. Kgit VMIs test VM. Kedit VMI test VM. Oh, did this open up in Vim? Oh god, I do not know how to use Vim. All right, so let's come down here. Disks, yada yada yada. Cloud init, type, container disk. Now, where would we define the size of this disk? Here's memory 64 megs. Let's try to edit this one and see what happens. I cannot, for the life of me, use Vim. This is embarrassing. Yeah, I hit exit a bunch. I think then you do this thing, and then you do this thing. And editor, let's change our editor here. Editor is equal to, we'll just use nano since Emacs probably isn't installed on here. Okay. So let's come down here. 64 megs. Change this to, oh, is this still VI? Yeah, oh my god, I hate this thing. Okay, anyway, let's see. Quit, right? That's all I know how to do in Vim is quit. Can we see what you're seeing? Oh, duh. Thanks for pointing that out, Ashish. I didn't realize we were still on my face here. No, it was just me goofing off in Vim. You're not missing you're not missing very much. Fabian says, yeah, you're screen sharing. Okay, thanks for calling that out, folks. Let's see if we have nano not found. Okay, let's yum install Emacs. Sudo bang bang. Yes. Gotta basically download the internet because it's Emacs. So yeah, we'll wait for this to download and then we can edit our file. I've made it, I think, 12 years in tech without teaching myself VI. I'm really proud of that. Okay, complete. So now let's go editor is equal to Emacs and kedit VMI test VM. And I bet we're still in, yeah. Quit. So let's see, where is Emacs? User then Emacs. Let's try this. Does the editor need to be in all caps? I think it does, doesn't it? Yes, finally. Okay. Got Emacs working. Let's scroll down. 64 megs. Happy edit file. So let's do 124 megs. And let's save this. Oh, it yelled at me. Let's just move it up to, let's do 80 megs. Huh. I guess it's not going to let me edit this. Let's change it back to 64 and see what happens. I'm curious about this live migration now. Okay, yeah. KubeVirt test VM is invalid. Oh, we would have to give it a different name. Okay. That's fine. Anyway, let's see if Fabian has anything. Okay, yes, yeah. So Fabian dropped something in the chat. Let's just pull this up and see what we can find. Okay. Oh, good. It's documentation on live migration here. Enabling the live migration support. So you go and you define this config map. You initiate live migration, virtual machine instance migration, migration status reporting. Okay, so it looks like there's this whole live migration system that KubeVirt allows you to do where you would be able to live migrate a virtual machine in the exact same way, in a declarative way, using the operator and declaring what you want as well. And we can jump more into that maybe in a second episode a little bit later. We're already an hour and a half into our episode, so I'm going to start to wrap it up. Do folks have any other questions or anything else they want to see while they got me here? And we have this pulled up and we can access it and take a look. I'm curious of what VirtCuddle can also do. Looks like we have image upload. We can restart. We can stop. If we had VNC installed, we could VNC into it. John Griffith says ASCII Cinema, screencast for anybody interested. I'll allow it. I'm not going to click on it though. David X. Johnson says interesting references to virtual machine replica set, making it possible to set the number of replica sets to scale. So yeah, KubeVirt gives you a ton of higher level primitives, like having virtual machine replica set, so you can actually define a set of virtual machines, and it allows you to do all of that in a declarative way. So overall, we got it running in Amazon. At the beginning of the episode, I suggested not to click on KubeVirt IO on these, but they were able to actually fix this like within the past hour even. So hats off to our friends at KubeVirt. Hats off to Fabian here for all of his help, helping me today and getting us up and running. And thanks again for joining us on TGIK. I guess everybody have a good weekend. Thanks for joining. I'll give folks another minute or two here to say goodbye, and I'll have like a sip of beer. But yeah, if you want to drop in and say bye, or if there's anything else you want to see, let me know and hit that subscribe button right here. Oh, John says that ASCII Cinema that he shared is a reference to the live migration. Okay, does somebody want to take the power of adding that to the documentation for us for the HackMD? Fabian says maybe also worth mentioning the common templates, which provides definitions for common guests, Windows and Linuxes. Okay, so we can kind of do like what we do with volume templates, where we can sort of define a template that we can easily exchange information into and out of that make up commonly used virtual machines for us that we could use. So maybe we want to define like, we want to have a large server, but we want to sometimes change the operating system. We could use templates for that. Alan Fraser, do you have a link for the Hangout after TGIK? We can get one. Follow me on Twitter. I'll retweet Nicholas's tweet that has the Hangout information. Alan, it's just twitter.com/Kris Nova. But other than that, I think everybody, thank you so much for joining. I love doing TGIK. I love hanging out with everyone. We'll see everybody next week. I think we're going to have one of my good climbing friends who works here at VMware named Josh going to be doing his first TGIK, so make sure to give him, a warm TGIK welcome. Let's see, Martin says, thanks and have a good weekend and enjoy working from home. Absolutely. Thanks, well done to get through all the issues. Thanks, Fabian, for all your help. You really helped save the day today. And yeah, this has been TGIK on KubeVirt. Hopefully folks learned a lot and got an idea of how we can schedule one or more virtual machines in a very flexible way using KubeVirt and KVM. So Alan says, many thanks. Have a great weekend. Thanks, everyone. It's been a pleasure. I will see everybody later. Have a good week.